Good morning to all. This video I am going to talk about statistical inference. First, I have to discuss about statistical inference. Statistical inference means consists in the use of statistics to draw conclusions about some unknown aspect of a population based on a random sample from that population. First, I have to draw the samples from that population. After that, I have to find out sample statistics values. These sample statistics values is its use is an unbiased estimate of population parameter value. First of all, we would like to know what is the parameter space. Let us consider a random variable x with the PDF. PDF means probability density function of f of x comma theta. This f of x comma theta is the general form of probability density function for any distribution. In most common applications, the functional form of the population distribution is assumed to be known except for the value of some unknown parameter theta. Okay, these theta values is belongs to a set of the capital theta. That means this is called the parameter space. For any unknown parameter theta is belongs to a capital parameter theta. It means this is the set of parameters, set of all the parameters. This is expressed by writing the probability density function in the form of f of x comma theta. Okay, here x considered as a random variable. The theta is called a unknown parameter value. These unknown parameter values is belongs to a capital parameter theta or a set of theta. The set theta, which is the set of all possible value of theta, unknown parameter value is called the parameter space. Next, the statistical inference, there are two types. One is estimation theory, another one is hypothesis testing. Then the first method, estimation theory. In this estimation theory, we are going to estimate unknown parameter values. Okay, this is the method of estimation. This is the method of estimation. There are so many methods of estimation. One is method of maximum likelihood estimation, method of moments, method of minimum chi-square, method of minimum variance, method of least squares, and method of inverse probability. In this video, I am going to talk about method of maximum likelihood estimation. First, we would like to know what is mean by likelihood function. What is mean by likelihood function? Let x1, x2, etc. xn be a random sample of size n from a population with a density function f of x comma theta. First, we have to draw the random samples from a population with a size n, and its density function is f of x comma theta. This is the general density function for any distribution. Then the likelihood function of the sample values x1, x2, etc. xn usually denoted by L equal to L of theta. Here L means the likelihood function of these unknown parameter theta. Here we have more unknown parameters. It depends upon the distribution. First, I have mentioned here capital L equal to f of x1 comma theta, f of x2 comma theta, etc. f of xn comma theta. Here I have given more joint. This is called the joint density function for each random variable x1, x2, etc. xn equal to pi I equal to 1 to n f of xi comma theta, I ranging from 1 to n. Next, the capital L, that means the likelihood function, gives the relative likelihood that the random variables assume a particular set of values x1, x2, etc. xn. For a given sample x1, x2, etc. xn, the likelihood function L becomes a function of the variable, the unknown parameter value theta. Next, the principle of maximum likelihood consists in finding an estimator for the unknown parameter. This is called the vector of unknown parameter theta. Theta equal to theta 1, theta 2, etc. theta k, say, which maximizes the likelihood function L of theta for variations in parameter. That is, we wish to find so that the L of theta cap equal to L of theta. The likelihood function of the estimate of theta, unknown parameter theta is greater than the likelihood function of theta. It belongs to the all unknown parameter values belongs to the parameter space capital theta. That is the L of theta cap, the likelihood function of the estimate of unknown parameter theta equal to supremum of L of theta cap. The supremum of means we have to maximize our likelihood function. Thus, if there exists a function theta cap equal to theta cap of x1, x2, etc., xn of the sample values which maximizes the likelihood function for variations in theta, then theta cap is to be taken as an estimator of theta. Theta cap is usually called maximum likelihood estimator. The unknown parameters of that vector of unknown parameters is called the maximum likelihood estimator. First, we should differentiate the likelihood function. The L means the likelihood functions. We have to differentiate. First order, differentiate with respect to theta. With respect to unknown parameter theta equal to 0. And the second condition, the second order partial derivatives, the dou squared of that particular likelihood function for any distribution divided by, we have to differentiate with respect to theta squared is less than 0. Since the likelihood function is greater than 0 and log L is a non-decreasing function of likelihood function L, then L and log L attain their extreme values. It means the maxima and minima at the same value of the vector of unknown parameter value theta cap. The first of the two equations in 2 can be rewritten as 1 divided by L into dou log L by dou theta. This is called the log likelihood function. Log likelihood function equal to 0. That is dou log L divided by dou theta equal to 0. A form which is more convenient from practical point of view. Next, if theta is vector valued parameter, then theta cap equal to theta 1 cap, theta 2 cap, and etc. theta k cap. Okay, these are unknown parameters values. For k unknown parameters values is given by the solution is simultaneously equations. That means we have to find the k parameter values. We have to find unknown parameter values. Dou divided by dou theta I log L equal to dou divided by dou theta I log L of theta 1, theta 2, etc. Theta k equal to 0. This I ranging from 1 to k. That means k unknown parameter values we have to find with the help of maximum likelihood estimations. The above equations 2a and 2b are usually referred to as likelihood equations for estimating the unknown parameters values from any distribution. Thank you.